So I like to think there are, hope you all can hear me. Okay. I like to think there are two kinds of people who really, really loves optimizations, and there's the rest of us in the world. So I will try to bring everyone more or less into the same ground, hopefully, at least in this specific form of optimization that we can do. So who am I? My name is Dulaj Disanayaka. I'm an engineer at STEX. I have a master's in data science and a bachelor's in computer science. This doesn't work. So I'm 31 years old, and yeah, skipping through that. Uh, I do photography in my free times, and as Aryan mentioned, I have moved to Netherlands in last October. So before everything, let me start by mentioning a few things I won't be talking about in terms of optimizations. I won't be talking about the fact that Python is a really, really slow language. It's 100% true. If you have been using compiled languages like C++ or Rust, you will know how slow Python is actually. That snail's name is Gil, by the way. It's faster now after Python 3.11. Actually, it has become reasonably faster, but more importantly, speed is not everything that we are looking for a language. Actually, Python has a lot going for it. For example, readability, maintainability, huge set of third-party libraries that's available around language. It's unmatched by any other language actually. If you want to get into more in-depth details about inner workings of Python, I would suggest you check out talk I think we have today called Python Under the Hood. I also won't be talking about switching your interpreter or using compiled Python. These are actually very legitimate methods of improving performance, but it's completely different topic that from the one that I will be giving today, so I won't be talking about this as well. So let's talk optimizations. So we are living in a world that we have a seemingly unlimited amount of resources, and because of this, we have this stigma around optimizations. It's mostly created by high-level language communities like ourselves. Here are few, basically two phrases that's been thrown around a lot. First one is that premature optimization is bad, and the second one is micro optimization is bad. So let's try to break this down a little bit. As you know, Donald Knuth once mentioned that premature optimization is the root of all evil. In the same phrase, he also mentioned that thinking about optimization or worrying about optimizations at the wrong time in the wrong place, it's not a good idea. So what is actually this wrong time? What is premature? Obviously, thinking about optimizations right at the beginning of your development process, even when you have not written any line of code, is too soon. And if you have to think about optimizations when you had a huge problem in your production system and you lost millions of dollars, is too late. So somewhere in between is the correct time. This premature optimization bad phrase is a little bit too vague. So let me try to concise that a little bit more. Premature optimization is bad because if you can get a higher ROI or return on investment when you allocate your resources on feature development or bug fixes, it's actually better than doing optimization early in your development process. But when you should switch from primarily on feature development and bug fixes to primarily optimization is actually judgment call. Let's try to break this argument down as well. So micro optimization is actually bad because basically when you have a very non-optimal code, you can get a higher ROI or return on investment again when you spend time on macro optimizations rather than spending time on tiny little details. So if you have an unoptimal system, you can get a higher ROI when you spend a lot of time on macro optimization rather than spending time on micro optimization. But the problem with this statement is that you should not consider the every statement in your code base equally, because, for example, some segments of your code base will be utilized millions of times than other parts of your system. The correct, I think, corrected way of thinking about this is that call path micro optimization is actually bad, rather than thinking micro optimization as a whole is bad. So we are coming back to this term return on investment. Optimization actually is a meta problem, because how, when, and where you spend your resources or developer resources doing optimization actually matters. So you have to optimize the time that you spent on optimizing your code. So we have this contention between spending time on feature development and bug fixes on one hand, and doing code optimization or code cleanup on the other hand. So, but there actually is a separate, third way of looking at this, which will allow you to develop features while keeping your code base clean and smooth as well. So that solution actually is opportunistic optimizations, which is actually completely made up term, just so we have a common term we can communicate this idea about. Opportunistic optimization is a combination of premature optimization and micro optimizations. So one level higher than the root of all evil. But more importantly, it's not, so unlike micro optimizations, you are not going through your code base with a magnifying glass, trying to optimize things as much as possible. It's basically like Boy Scout rule, if you are familiar with that, but more specific for optimizations. Basically, you try to make your code base a little bit better than you found it. This last point is really important though, because you should not be pressured to optimize your code base every time that you touch it, because that might be impossible for you to do, especially if you are applying this kind of regular optimizations, micro level optimizations when you are developing your code. So this is actually a very passive thing that you would do when you are doing your feature development. Again, the idea is to passively keep an passively keep an eye out for simple improvements that you can do, and these simple improvements has to amount for huge performance gains, at least in the context that you are working on. Lastly, it's not a strict set of guidelines that you should follow when doing this. It's basically a mindset that you develop or master as a developer to be able to apply opportunistic optimizations. The gist of it is to make that phase when you see an non-optimal or suspicious code. There are two traits actually that you should master as a developer when you try to apply opportunistic optimizations. The first one is to keep an abstract idea about your entire code base, or at least the segment that you are working on, and performance implications a certain decision has on the grand scheme of things. And the second one is to know your know your tech stack, your language, and the framework that you are working on better, to be able to overcome those performance implications that you come across. It's not necessary to know every nook and cranny of the tech stack that you are working on, but at least know how to find answers when you come across an issue. So there are a few points that I also need to point out here. Again, you are not compelled to improve your code base every time that you touch it. It's again, it's if the code base is good enough in your set of standards, just don't try to improve anything. The second point is you should not be, so these should be really micro optimizations that you do. You should not try to make any major changes to the flow of your system. The third point is really important. If you know your system, if you know your tech stack really well, you will know ways that you can squeeze out some performance by going through some weird alleys. So just don't do it, because most of the stuff will be fixed in the future, and you will be left with some confusing and most probably non-optimal code as well. Lastly, don't compromise readability in favor of performance. If the stakes are high enough, you are allowed to bend the rules, but always try not to do that. So that's the basic idea of it. Let's try to go through some examples to elaborate what I mean by specifically by these micro optimizations that you can apply in day-to-day life. So this first example is about inbuilt functions in using inbuilts in Python. If you know, so again, Python is a really slow language, but inbuilts in Python are written in low-level C. So try to push things to inbuilts in Python as much as possible if you could. Here we see that we have this pair my meals function, which takes 3 lists. We are doing some stuff to clean out the data, removing none and empty fields. And then we are trying to get all combinations of wine, cheese, and meat here. And we are trying to increment an index here as well. One thing you should know is that for loops in Python is actually 50% faster than while loops, just because we are not doing this increment operations in for loops. So try to not do these kind of things as much as possible. Going in, we see a huge problem that we are calling this get pair in score function twice on each iteration, first to get to this if statement and to print the output as well. And then we see we are trying to print some things, formatting things by using this concatenation, which is also really bad idea. So again, make this face. You will see these issues. Let's try to improve this. First of all, you can use list comprehension. So right here I have used generator comprehensions, because using this you won't need to store everything in your memory. And to get all combinations of wine, cheese, and meats, you can use itertools product function. And since we need to get incremental index as well, we have used this enumerate function to get that. If you want to get an bind a variable to an output of a sub statement, you can use this Walters operator. So here I have used the Volta separator to get this pair in score, and I have printed that here. And instead of doing string concatenations, we can use f strings to format this output as well. One thing you have to know about f strings is that if you are doing if you are using f strings with string formatting in Python, there are some security implications about that. Just be aware of that and read about it when you are using it. So this looks nice. Let's move on to the next example. So this is about Python data structures. Here we have created this coordinates class, which contains, which holds XY coordinates. Using this kind of very generic class just to store this coordinate looks like not good. It looks like not a good idea, but let's come back to that. Here we have created 5 coordinate objects, assigning that to a list in NPC coordinates. Let me look at if I have time. Yeah. So just for the sake of the argument, let's assume this number of coordinates in these NPCs is static and it's 5. And after that, we have written some logic to remove any duplicates in this NPC coordinates list. Also, we have better ways of doing this. So these should trigger these kind of responses in your head. So let's try to fix this. First of all, you can use a data class to store XY coordinates. Since this data class is actually static, you won't be dynamically adding any arguments to this class. You can define slots equal true, which is Python 3.11 feature, as I remember. Since I will be using this in sets, I have defined done the hash function here as well. Just ignore that for now. And since we are assuming this number of NPC coordinates is static, we can obviously use a tuple to store these values. Then we can actually, to get rid of duplicates here, we can use a set which will automatically remove any duplicates. Here I have used frozen set because the length is actually static. So again, this looks better. Let's move on to the next example. So I have this email utility class which contains some utility functions that you can reason about emails. First function it has is this checker for to check if an email is valid or not. So immediately looking at this function, you should see that this self object is not used here. So the scope of this function looks a little bit wrong. But more importantly, inside that function, we have compiled this regex to identify if a given string is an email or not. But every time this function gets called, we are recompiling this regex, which is not a good idea. So the scope of this regex seems wrong. We have this function to check if email exists in the internal private list. Again, you can see that this emails list is a private variable, and we are not assigning, changing that variable anywhere in our code. So the output of this function for a specific email address is the same. So we should be able to cache that. Again, same thing for email counts. The output is static, so again we can cache that result. More importantly, when you get to this get whitelisted email, it checks if an email exists in a if all so it tries to get all emails that passes this checker. and it limits it wants so we want to limit the number of results we are getting using this limit variable. So what we have done is we have created this list of whitelisted emails, and we have returned a subset of that whitelisted emails here. So again, you should see all the things I have mentioned, and here also you should see that we are trying to evaluate everything just to get a subset of the result that we want. So let's try to fix this. First of all, we can make this isValid email a static method because we are not using the self object. And I have assigned this regex into the function object itself, but this might be a little bit controversial. If you don't like this, you can obviously keep this compiled regex in the object itself or as a class variable, but it's your preference of readability, I guess. Moving on, we have made this email exist function. We have cached the result of this email exist function. Since email count actually is not getting any inputs, we can make it a cache property, which is a little bit faster, but you don't have to consider the performance difference between cache and cache property. It doesn't matter a lot, so it's actually preference. More importantly, going down into this get whitelisted emails, obvious choice for this is a generator. For us to lazily evaluate things rather than evaluate everything just to get a subset. So we have used this filter function to get a generator that will filter out the list based on this checker. And we have used an isSlice function on top of that generator to limit the result we are getting from that. So those are few examples regarding Python internals, but there are a lot of third-party libraries out there that are written in low-level C that actually can be used for the same purpose, depending on your very specific requirement. I have given one example here about NumPy arrays. If you know, Python actually has, when you use a Python list, we have to go through 2 levels of indirection to access a object. But more importantly, the data in, when you are accessing these objects are scattered throughout the memory. In contrast, if you take a look at NumPy arrays, all the data is one chunk in the memory that is stored consequently, and you have one level of indirection as well. So you will get fast access, and because of spatial locality, you will get hardware level caching as well if you use NumPy arrays. So few things I have not mentioned. Match statements. If you know switch statements in other languages, you might be thinking Python match statement is something similar. But because switch statement actually are really fast because they are using jump tables internally to jump between cases. But match statements in Python, which I introduced in Python 3.10, I think, is not implemented like that. It's just some if-else statements underneath. So you won't get any performance improvements out of that. Multi-threading, of course, Python doesn't have real multi-threading because of the global interpreter lock. And also using multi-threading, multiprocessing, async IO, you will have to do a lot of changes to your architecture, which is not the idea of opportunistic optimizations. There might be other things that I have not mentioned, maybe because I don't know, most probably because I don't know them, but maybe I don't have time, but you can be the judge of deciding if that's usable or not. So final notes, we have talked about the problem, which is the scarcity, the balance in between scarcity of system resources and scarcity of man hours or developer time. And we have discussed one solution for that, which is opportunistic optimizations, passively looking at simple improvements that you can do on your code base to gain significant performance improvements. We have discussed two ways, two traits that you should develop as a developer to do that. First one is to have a good understanding about your code base, and the second one is to have a deeper knowledge of your tech stacks so you can apply solutions to overcome performance implications. Sorry. Again, this is not an active thing that you do. This should be a habit or a routine more than a last level thing that you can do to gain performance. So don't try to be that guy. Lastly, you have been most probably you may have been doing this all along, but it's nice to have a name for it so we can discuss it and develop as better developers. So that's pretty much it. If you want to connect with me, you can connect through LinkedIn, and I have a small YouTube channel as well, but I don't have any videos there. So thanks.
Thank you very much. There are still a few minutes left for questions from the audience. Does anyone have a question? Let's start here in the front.
Well, I want to be the top guy you showed in the one slide, but you need to make it a habit. Do you have any places where you can find like basics or tools? You mentioned a lot of great examples, but is there some place where you can start and find these things to make it a habit?
Yeah, the thing is, when I try to, so I have been doing this all along, but the problem is I couldn't find any real name for this. So I think it's not a standard way of thinking about things. So one thing I would suggest you is, if you find a solution for a problem, try to generalize as much as possible. So Feynman technique. So try to explain things to a 5-year-old. If you can do that, it will be stuck in your head, so we'll be able to reapply that. Other than that, yeah, just read documentations, I guess.
I think if anyone finds like these quick optimizations, they should email you, and you could start your YouTube channel with.
Yeah, please do.
Explaining it. There's a question all the way at the top. Can you give an example of the performance improvements that you gained by doing opportunistic?
Yeah, so using cache, probably you will get 100%, nearly 100%. Basically, you won't do any calculations there. You will, internally you will do so it will be stored in a dictionary. So you will do a dictionary lookup. This is more faster because it will be, so if you use a cache property, it will be saved in this class object as a variable, so you will get fast access. I don't have any performance profiled on this, but I would so it's not about doing profiling and understanding where are your problems. It's about, when you write this code, knowing that this shouldn't be in this scope. It should be in a higher scope, that kind of things. So snap decisions as much as possible to make things a little bit cleaner.
Yeah, thank you. One more question, if there are any. I don't think so. Well, thank you, Dulaj.
Thank you.
I have a small gift. Yeah.